Hello, everyone. We'll just
Morning,
wait.
Rustam.
Morning, morning. We'll just wait for a few more people.
Nice last day before the long weekend everybody is planning to take.
Okay, so this is Rustam and Saura.
Hi, good morning.
Good morning.
Hi, everyone.
I'll give around 2 to 3 minutes to people to join.
Yes, we'll wait a few minutes.
Is it two of you in the office, is it? Rustam and Saurabh?
Yes, two of us
Yes.
here.
Yeah.
Okay, so let's start. Other people might join in as they come along.
Okay. So to start with this session series, Dr. Rustam Kanga, he accepted the offer to start with AI and what is types of AI we are talking about, what is the landscape. So we'll get a brief understanding today, and then we'll have a chat on the WhatsApp group, the next session, and who can be the moderator or facilitator for that. Okay, to you, sir.
Thank you. So let me share my screen. I presume you can all see my screen now.
Yes, we can.
Good. All right. So today we are going to talk about what is artificial intelligence. And to do that, I think the first thing we have to do is to determine what is intelligence. So artificial intelligence is really about replicating human intelligence. Now, when we think of really intelligent people and what is human intelligence, we can think of people like Da Vinci and Shakuntala Devi and Stephen Hawking and so on. But in fact, there can be uh, very fundamental low levels of intelligence that you can start with. For instance, even animals have intelligence. Cockatoo that knows how to open a bin because it knows that inside it'll find things to eat is intelligence. And in fact, you'll notice that if one cockatoo has figured out how to do it, then all the cockatoos in the neighborhood will learn from him and do the same thing. Another example of animal intelligence is Coco. Uh, for those who haven't heard of Coco, Coco was a gorilla. He was brought up in San Diego by two psychologists who brought him up like a human child. So they would talk to him, they would read to him every night, read stories to him every night, and so on. They treated him just like a human being. And Coco died recently at about the age of 43. And she, uh, in that time, had had acquired a vocabulary of about 3,000 words. It Coco had learned sign language, just like deaf and dumb people can, because it was not verbal. And so it had the intelligence of about a 3 or 4 year old child, which is very interesting because it shows that it's not just humans who have intelligence. So when we talk of intelligence, what are we looking at? There are many forms of human intelligence. There is deductive reasoning. We know how to do logic, right? We say if A, then B, if A and B minus C, then something else, and so on. We have memory and experience. We can remember things and we can learn from that. We have creative, intuitive thinking. We can invent things. We have sensory perception. That means we understand what is happening in our environment around us. We have language, so we communicate with each other. And we also have feelings and conscience. And so all these are parts of what we call intelligence. So as we get into how we get computers to replicate human intelligence, let's look at one of the first things that we get computers to do, and that is machine learning. And in fact, a subset of that, which is deep learning. What is deep learning? Deep learning is a technology where it exercises the memory function. For instance, if you want to recognize a dog, you can get 50,000 images of dogs, and you can say that is a dog, that is a dog, that is a dog, and so on. You label them, you train your system, and then at the end of the day, when the next dog comes along, you know that it is a dog. Now you can have supervised and unsupervised machine learning. How does that work? Just think of a child. If you gave it the complete works of Shakespeare and said, go read it, and over time, the child would figure it out, and maybe in many, many years, it'll understand everything that's in that volume. On the other hand, you can have a classroom and you can teach a child. You can say, when Hamlet says to be or not to be, this is what he is thinking, and so on. So you can train the child, and you can do it much, much faster, but it involves human intervention. And it's the same with machine learning. You can have supervised machine learning where you teach the child, teach the machine something, and you can have unsupervised machine learning where you just give it data and you say, figure it out for yourself. Now, with machine learning, you have the usual problem in IT, which is garbage in, garbage out. And I'll give you an example. When one of the initial chatbots was created, something like Alexa, where you can say, Alexa, switch on the lights, Alexa, tell me what time my next meeting is, and so on. When one of those first chatbots was created, a group hacked the system, and they started talking to it with swear words and foul language and so on. And the chatbot learned all that. So it started repeating that and started talking to people with swear words and foul language. And they had to actually stop that and recall the product because it had got totally out of hand. So essentially, it shows that it's garbage in, garbage out. You have to train the system, but you have to train it with what you want it to know. So the pros of deep learning and machine learning is it's fairly easy to do. It requires very little human intelligence. You just figure out what you want the system to know and you tell it. And there are many products in the market that allow you to do that. The cons is that it's a very labor-intensive exercise. You have to label all your systems. You require very huge, never-ending data sets. You require massive computing power, which is why companies like NVIDIA and Google promote it, and it makes them rich. Also, it tends to be a black box to humans. Once you've told it what you want it to learn, you don't know how it's learning. It's impossible to provide human input to understand when it's making a mistake. So you cannot always rely on the results. Just because you don't know if it's learned the right thing, you don't know what it has learned. Today, you have a new version of that called generative AI. It is very, very advanced deep learning using very large data sets to generate responses based on known knowledge. So you can, ask it to write essays for you. You can ask it to create a picture for you, but it's based on known knowledge. So for instance, if you said, make me a picture based on all your knowledge of paintings in the past. So it could paint a picture based on an impressionist style or a Renaissance style or any other style, right? But it's only based on known knowledge. So if it was in the 1920s, it could not have created a Picasso just because Picasso-type paintings did not exist before then, right? So it could only paint pictures of the type that it knew about. So even with generative AI, you find it's useful for known knowledge. It can go back and do things based on what it has been taught, but it cannot actually truly create something imaginative and new and different. The other challenge with machine learning is the problem of unavailable data sets. So we did a project for the Hong Kong prisons where they said, we want to detect people committing suicide. Now, how do you get 50,000 people to commit suicide? You can't do that, right? You just won't have the data set. So what is the alternative? So how would a human know that somebody's committing suicide? You would say, oh, he's standing on a chair, he's got a rope around his neck, he's about to commit suicide. That's how a human would do it. And so how do you replicate that in a system? So for that, you have a different form of AI, which we call heuristic AI, which is based on the logic function as opposed to the memory function. Here, you teach the system some rules. In that case, you'd say if somebody's standing on a chair and he's got a rope around his neck, then it looks like suicide. So the very earliest heuristic systems were called expert systems. And essentially what they did was they did a brain dump of how humans made decisions. So for instance, some of the very early systems were for in the medical field. How does a doctor make a decision? You go to him and you say, I've got a pain in my stomach and I've also got a pain in my head and my eyes are red. And the doctor will go through some logical process in his mind and say, look, I think you have this ailment. Now, what is that process that he goes through, especially when all the information may not always be there? And so the very early systems essentially tried to replicate the logic that humans use to make decisions. And in fact, I was involved in a very early expert system for a building company. This was back in 1980 or so, where they used to have a person who'd go to a building site and he'd walk around it and he'd estimate the cost of putting up the building. So if they wanted to put up a building of 70 stories, he'd walk around there and say, yeah, it'll be $62 million. And he was usually right within 5% or so. The problem they had was that he was about to retire and they had no one else who could do this. So they wanted to do a brain dump of, how does he think? How does he make those decisions? And that is what some of the earliest heuristic systems were. Now, the pros and cons of a heuristic system are that pros are it's very fast to implement because once you understand the logic, you can put in some fairly simple logic and it'll work. It's easy to modify because you know what the logic is. You've understood it before you explain it to the computer. And it tends to be very computing light. It does not require GPUs and other, specialized computing. The cons is that it requires humans to set the rules. So it's not automatic. Somebody has to really know what the rules are before you can teach the computer. The fact that you don't need GPUs is very interesting because it helps to reduce carbon footprint. Not only are GPUs very expensive, they require an enormous amount of power. And so if you want the system to be sustainable, one way to do it is by not using GPUs. So we've talked of a couple of aspects of human thinking. What about feelings and conscience? How will we ever get a computer to develop a sense of feeling, a sense of love, a sense of conscience? You could do it with some heuristics. For instance, you could say slavery is bad. You could teach the computer. But even humans struggle with ethical questions. So we are very ambiguous in our minds on what is good and what is bad. And if we don't know what is good and what is bad, it's very difficult to teach a computer. So this is one of those areas that's probably quite far into the future before we can give computers this sense of intelligence, emotional intelligence, and so on. So we've talked about different aspects of human intelligence, deductive reasoning, creative thinking, memory, experience, and so on. The next thing is sensory perception. How does a human understand what's happening around him? And how do you get a computer to understand what's happening around it? And so humans use their eyes, their ears, their nose to understand what's happening. And so for computers, you have multisensory analytics. You have video analysis, you have sound analysis, you have smell analysis, all working together. So let me give you some examples. You've probably all seen face recognition systems at the airport where they say, stand straight, take off your specs, don't smile, and they'll recognize you. In fact, this is an area of our own specialization, and we can do face recognition in a crowd. So here you have 100 people in a scene, and you can recognize all of them at very low resolution, on very low resolution cameras without a GPU. You can do behavior analysis, behavior like people leaving bags, people slipping and falling, people doing graffiti. It can be behavior of people, it can be behavior of cars, cars going the wrong way, cars having accidents. It could be anything. It could be rats in a restaurant, where are the rats coming from? And the system needs to understand that. It can do recognition in terms of license plate recognition and so on. And, it has to be done in multiple languages. So we do it for 120 countries in Chinese and Arabic and so on. So that is video. That's understanding sight. The next thing is understanding sound. Things like gunshot detection, understanding people shouting and screaming, glass breaking, and so on. And finally, smell. How, for video, you have cameras, for sound, you have microphones. How do you smell? How can you get a computer to smell? So for that, we have something called an e-nose. Now, it doesn't look like that. It actually looks like this. So it's a little device that we've got where as the air goes through the device, it'll tell you what is in the air. Now, what can it be used for? In an airport, say in Delhi airport, they clean the toilets every 4 hours. But it might start smelling after 1 hour. So the system, if it smells that the toilet is not clean, will say, oh, come back and clean toilet 6. It can be used in food production. We have a customer who's making chocolate, and as they bring in milk, which comes in trucks, but it could have gone bad in transit. So the system will smell it and say the milk is good or it's bad. It can be used in old age homes and in hospitals for human incontinence and so on. So there are multiple use cases for this. There are other domains for AI because, for instance, with motion, humans move about, walk about, but to move, we actually use our brains to manage our motion. And so the whole field of robotics is very heavily dependent on a level of intelligence in the computer. There's also the misuse of technology. People can hack into the systems, and therefore the system has to be aware of somebody hacking into it. And that brings in the whole field of cybersecurity, which is not AI in its own right, but it is related to AI. So we've talked of the different aspects of AI. What is the use of AI? I mean, does society really need AI? How does it help us? Let me give you a few examples. In Brussels airport, they had a bomb go off. This guy on the right, you might remember his image. He left a bag, it blew up, 30 people died. They caught him after 3 days. Why did it take them 3 days? It's because people put in these lovely big video walls, and they expect this poor guy to actually see something. And studies have shown that if you're watching only 2 monitors, after 10 minutes, you miss half the action. After 20 minutes, you see nothing. So it's pretty useless to have this sort of situation. And yet, that's what they have, because they put in hundreds of cameras and they expect somebody to see it. And of course, humans are concerned about, oh, Big Brother is watching us, they put up cameras and so on. It's not a relevant concern because, in fact, this is a typical control room in one of the railways around here. You can see the poor guy is watching nothing, right? So what is the alternative to that? Let me paint you a different sort of situation. In Singapore, they had a riot in a place called Little India. A bus ran over a laborer, it killed him, his friends got upset, they set fire to the bus. Over there, see their reaction. 9:23, the accident happened. 9:25, 2 minutes, the police are there. 8 minutes, the ambulance is there, then the fire brigade. In 1 hour, they've all gone home. Next day, 24 people are charged. How can Singapore react in 2 minutes? And in Brussels, it takes you 3 days. What's the difference? And the difference was in Singapore, we'd implemented an autonomous response system, an AI system, where the camera itself understood what was happening. It would find the nearest policeman. If it was on fire, it would find the nearest fire brigade and so on, and tell it where to go and what to do. Let me show you a little video now, which helps you visualize how this whole system actually works in practice, because then you'll understand the true value of AI.
Our omniscient speciality is the ability to provide multiple video analytics in very complex scenes. As you can see, a person has dropped a bag. He has abandoned it and he is walking away. The bag is being obscured by people walking in front of it, and it is hardly visible. The system has found the bag. This is our speciality. We can cope with situations where the object is significantly obscured. We now do the jump to event, which takes you back to the moment that the bag was first brought into the scene. It doesn't matter how long back that was. The system can see who left the bag. You can pull out his face and enroll him in the watch list. This face can then be transmitted to all the other cameras within the network. At this stage, we don't know who that person was, but we do have an image of him, and we can search for him across the various cameras in the network. Now, in this view, we have seen the person again, and we can pull out whatever additional information we have about the person. The next step is to track him. We can track him on different cameras, where we have seen him, and we know that he is finally now at that last camera shown in red. From that point, we can find the nearest policeman, and the system sends the information to him on his smartphone. He will ask who this person is, and we can send him as much information as we have on him. He will ask what he has done, and we can send him the jump to event video. The entire process is patented. The ability.
Okay, so that gives you an example of all the different types of intelligence working together. So it involved perception, understanding what was happening. It involved heuristics. It involved machine learning and deep learning, and all these different things working together actually ultimately create a solution that then becomes useful to society. And the value of this is in many different ways. It helps to make society more productive. As an example, in Sydney, you have 2 train systems. You have the Sydney trains and you have the Sydney Metro, which is a driverless train. And the Sydney train has drivers, guards, and so on. And they have a huge control room in Redfern where they have 1,500 staff. And despite that, they have something like 40 fatalities per year. The Metro is different. They have an autonomous AI-based system that we put in as a safety system. It's a driverless train, but it has its own control room with only 9 staff. And they've had 0 fatalities since inception, right? So the value to society is that it costs you much less in future if systems don't have to run with traditional technology and humans and so on. You can bring the cost down. Your tickets won't cost you $10 to go from the city to Hornsby. It'll cost you a fraction of that. Another example, in the Hong Kong Metro, they have something like 5,000 escalators. At any time, 1,000 of them are not working. Why? Because little nuts, bolts, coins fall into the escalator and damage it. and then it takes them 1 or 2 days to fix it, and it's inconvenient for everyone. So they wanted to solve that problem, and they asked us to check if something has fallen on the escalator track. And if you see a nut or a bolt or something like that, you can stop the escalator, brush it off, and that prevents the damage to the escalator. The benefit of that was that you had a very high ROI. The payback period for the system was only 8 weeks. And where do you get an investment that pays you back in 8 weeks, right? So this wasn't something, it wasn't part of the IT department, because the IT department doesn't have a focus on maintenance. That's part of the mechanical engineers who do the maintenance, right? But so here you have an example of an application which is outside of the IT space, which helps solve problems that are important to society. Another example, I talked about smell. Well, one of the things we've developed is we have a smell system where when you breathe out, the human breath can be used to analyze lung cancer, breast cancer, and so on, other upper thoracic diseases, which is interesting because you can reduce the cost of having to have MRIs and X-rays and other things, because it's a very, very low-cost way to diagnose some of these diseases. So now everybody's talking about AI. The key is how do you make it happen? Because while people are talking about it, nobody actually has done it on a large scale. So what you have to do is the experts in this have to analyze the risk points, the pain points, what are the problems that have to be solved. They've got to redesign the human processes to interface with the computers. They've got to then design the computer systems. They've got to implement it. They've got to support it. These are all things that companies do now for organizations who want to implement such systems. But even after it's implemented, there are still limitations of AI. As we discussed before, can AI systems be truly creative? At this stage, they can't be. Can AI systems develop feelings and conscience? At this stage, we haven't figured out how to do that for them. So there are still limitations. And there are many things that computers cannot do. And for that, we have to build good human interfaces to the artificial intelligence system. Let me give you one example of this. Face recognition systems are fairly accurate, but let's say it's 99% accurate. That still means there's 1 out of 100 wrong. And if you have 100,000 people going through an access point, that's many, many wrong people. So computers can be accurate, but only to, say, 99%. Humans could not look at 100,000 people and say that this is Johnny and this is Fred and so on. But humans are good at looking at people, and one-to-one, they are able to know if this is Johnny or Fred. So what you do is you use the computer to do the mass face recognition to understand, hey, is the person you're looking for in this crowd? And then you get a human involved to make that final decision to say, okay, I think it is this guy, but you go and confirm whether it is, right? So by using the two together, you get the benefit of the human's ability to do certain things, combined with the benefit of computers who can process very large quantities of data. I thought I'd just go back and look at what IIT graduates are good at in terms of intelligence. If you look at that pattern, you'll probably see that IIT graduates are good at deductive reasoning. We are good at logic and so on. We are good at memory and experience. We are probably not so good at some of the other things like being extremely creative, maybe even having emotional intelligence and so on. So while we view ourselves as being very intelligent, it's intelligence in certain domains. Now, a few final questions. Will AI kill jobs as we move forward? When the motor car was first invented, if in those days, there was lots of employment in saddle making. If you were a saddle maker, you could have a job for life because everybody had a horse and everybody needed saddles. When the motor car came in, those jobs just disappeared overnight. But does that mean we had large numbers of unemployed people? No, you had people who were now building cars, who were building spare parts for cars, who were maintaining cars, who were becoming chauffeurs and truck drivers and so on. So it created whole new industries. And I think that's what will happen with AI. Everybody's concerned about the jobs it'll kill. It will also create many, many new jobs. The other questions we all need to think
इतनी
about.
सही कंपनी यार इनकी आई जो मेरे को पता नहीं था कि ये लोग
The other thing we need to think about is the ethics of AI. Can you use it for good? Can you use it for evil? But that is true for all technologies. You saw just recently with the knife attacks, a knife can be used to kill people, but it can also be used to cut birthday cakes. So it's not the technology, it's the people who use it. I think we in society need to figure out how we want to use AI, and we can decide how we use it for good. So I think that was an overview of AI from me. I'd like to thank the IIT Alumni Association for setting this up and allowing me to take you through this. And if you have a few questions, I'm open to them. We have a few minutes left.
Yeah, thanks, Rustamji. And please ask the question. We have few minutes left, and also you can send the question on the WhatsApp group.
I got a question for Rustamji.
Yes, go ahead.
Excellent presentation, Rustamji. Quite
Wait,
enjoyed
I
it.
can't hear you. I'll just try and increase my sound. Yeah, go ahead.
Can you hear me now?
Yes.
Excellent presentation. I thoroughly enjoyed it. A very nice storytelling as well. Just wanted to understand. I'm aware that when you talked about the smell recognition, I'm aware that there's an array of chemical sensors that can be utilized, which basically absorb the volatile materials and actually generates the digital signals. And that's how actually you recognize smells. Obviously, it has to be well calibrated. What I am trying to understand when you say that you are analyzing human breaths and trying to diagnose a few diseases, how well correlated are those smell producing those volatile materials with the disease, some of the lung disease or upper thoracic diseases that you talked about? How well established those correlations are that will determine that how good the diagnosis are. So any sort of any light if you can shed on that.
Okay. So you get sensors for particular chemicals. So you can get a carbon monoxide sensor, you can get a hydrogen sensor, and so on. But they are usually for single chemicals. So that box I showed you is actually a box with about 6 different sensors in it. And they analyze a range of chemicals. And by understanding the combination of chemicals in those 6 different sensors, you can know what it is, whether it's bad milk or whether it's toilet smelling or somebody smoking or whatever, right? Now, what we have done is we've done clinical trials with people who have lung cancer versus people who don't have lung cancer. We've measured their breath and we've understood the pattern of smells that you get from the breath of different types of people. So if you have lung cancer, early stage lung cancer, you are emitting certain chemicals from your body, which are different to what a healthy person emits. And if we can pick up that pattern of smells, then essentially that's what we've done. So we've based it on empirical data. And the results we've been getting so far are about 95% accurate, with very high accuracy. So it's a good early stage diagnosis. Of course, once you've diagnosed it, then you have to go and do many more in-depth tests and so on, which doctors will do.
Very good case study, actually, Rustamji. Just one question.
obviously this is the supervised learning you might have done. So any algorithm you want to reveal here, that actually what algorithm is there to get 95% accuracy? Maybe combination of algorithms.
Well, we have something like 70 international patents,
Yeah.
which I've got. And of course, patents are published, so you can just go and read them. They're all in the public domain. Of course, the way we do patents is we don't publish everything. You publish certain things, and the rest you keep as trade secrets, which
We already had a good discussion on that on WhatsApp.
I know.
So maybe we can also talk about the next session because we have only 7 minutes left for the next session. What do you guys think? These sessions are helpful, or we should continue till we get the clarity what we are trying to do with this group, where we have a different level of understanding for AI machine learning. So what is the thinking here?
I think sort of like the great initiative. We learned a lot of things from Rustamji today. If someone else has got similar level of expertise, and it could be in different sectors, and they wish to, sort of present their expertise and share a little bit of stories, that would be great.
Just, sir, I wanted to say, just amazing presentation. Also, few of the snippets that you've provided about your own company, just insanely good, path breaking, I think, in many respects. So thank you so much for sharing all that knowledge with us.
Rustamji, I got a question, Rustamji.
Yeah.
I mean, it's an excellent use cases, demonstrated superbly well. I mean, I think your company has so much of a broad varieties of AI use cases being given. It's not in a one domain in one technology scope, right? So probably it's kind of a different question. How did you, how did you come up with varieties of use cases to solve in different fields, right? And how much stuff how much time and effort you put in, what technologies behind the scene? Probably, if you can summarize at very high level.
Well, when we first started, as I said, we started with in the expert systems field, and essentially we were going around solving customers' problems, right? So, say in the field of video analysis, we first developed the ability to detect, say, a left object, an abandoned object like a bag. And then people said, "Oh, but that's no good. We want to do it in a crowd." Right? People are walking in front of it. So initially you use motion detection. You understood the background. You said, what's in the foreground? Something's been left there. We can understand it. But then in a crowd, if it's in an airport, everything is moving. So you can't use motion detection. So then you had to say, so how would a human do this? And essentially we went through this whole process of understanding how a human would think to then the technologies for this. Our systems are very computing light, and we don't need GPUs because when we were doing all this, there were no GPUs. So we were forced to build very computing light algorithms. Today, of course, you have much more powerful computers, but they're also much more expensive, right? So there are pros and cons. The technology does move forward, and it's not that we don't use deep learning and machine learning and so on. We do. But I think we use a combination of these various different types of AI. And by using the combination, you tend to get the way humans think. The humans don't think in any one particular way. They use a combination of types of thinking. And so that's what we've tried to replicate.
Okay, I think we are
fabulous. Thank you. Yeah.
Rustamji. So since this is a volunteer group, so I would request people to come forward and tell us what topic they want to cover in and when, approximately how much time. So that would be good to schedule the session.
So thanks a lot, Rustamji. It was a wonderful presentation. I have never seen somebody explained AI in such a simple language. I'm a beginner, so I wanted to ask you one very relevant question. Like, if I want to start learning about it, what should I do? Like, what is the literature, or what are the any relevant books which I should look at? If you have, like, I'm open to suggestions from the group as well. M- my background has already like all been in finance, and my motivation is basically use AI to generate trading signals, which I know a little bit of programming, but I'm not at that level that I can start putting my what I know in my trading. Like,
Well,
I
in
want to
our
make it
yeah,
efficient.
well, in our group, I think we have several professors of AI, so maybe they can tell us, give you more information on how to start and how to learn and so on, right? I think they'd be more competent because my expertise is not in teaching. But I can give you some books and so on that you can refer to, but they
Yeah,
might.
you can share in the group as well. Actually, that
Yeah.
that
Yeah, I
should
think
be
others in the group may be more competent at teaching.
And Rahul, this is the objective, right? So when we move forward, we will get the guidance from the different people, different who are actually expert in different areas, and that is the whole objective. So maybe there is one professor also from the
Yes.
UNSW, right? We can ask the guidance from once we get matured, right, and we have a good interaction, we can definitely have these things sorted out, Rahul. I hope so.
Okay. There was one other person who had a.
Yeah.
Thanks. Sir.
I was trying.
Thank you, Rustamji, for the great presentation. I really enjoyed it.
Okay. Sorry, there was.
And I was just wondering. So although this was a very good start for this group, it would also be maybe a second or a third potential presentation could be around actual work done and the core idea behind that and the core heuristics or the core algorithm that was used and what the results look like and that sort of thing. Not to breach any intellectual property, but just to get some added motivation.
Sure.
Basically,
One
real
other-
use cases, right? Real
Yeah.
use cases, what we have done.
Yes, yeah, that's right.
I noted
Sure.
down.
So one other person.
Ashish, you had a
Yeah.
question. Yeah.
I was just going to say, like, I think like my question is coming like after listening to him that there are two different levels right now. Like, one is beginner like me, and one is like who has some experience already and are trying to ramp it up a little further. So, like, can we break it down into two groups, like beginner and like a little, let's say, intermediate or advanced? And like for beginner like me, like first stage can be like just an overview of like these are the steps. Like, you collect the data, you clean it, then process it, train it on the model, and test it again, and fine tune it, and then put it in your systems. So something like which explains the process, but very highly overview, so that we can know like how complex this is going to be. Should we step into this direction, or we hire someone expert? Let's say for Rahul sir, let's say if he wants to do something, like he can hire an expert who can train the model for him. He doesn't have to learn he can input his expertise in that field and help out with the model itself. So that kind of.
I think Ashish, the thing is 60% people in the first call, they said, okay, they are new to UI or they want to learn. So what we assume that it is initial sessions, what we are running will be, for beginners one to understand what is AI, which area. And then if you are interested in any area, you can actually deep dive. You can suggest that what you are looking for, and then we can work out within the group with the experts, right? So everybody is not joining, right? We have 42 members, but everybody is not joining. So initial sessions, what we have set up is mostly for basic understanding and things, and then we can go into the deep in the components of AI slowly. That's what the plan is.
Saurabh, Amit, absolutely agree. These 101 sessions are very important. So everybody in the group who's interested is on the same playing field when we go into the deep dive sessions. So for all of us who are beginners, amateurs, professionals, it's more for the amateurs and the beginners to come at the level of maturity to understand the basic 101s of the AI world. And then we can have those breakout sessions that we were talking about last week to create those subcommittees kind of stuff.
Correct, sir. That's what that's what the thinking was. But I'm happy to take the suggestions and we can organize the groups in a way people want?
So I live and work in Canberra, and this kind of a group is like a must for me because I don't really get to have that kind of a social setting. I work for government offices as a consultant, and I do what they like me to do. I don't get to work on what I like to do, and this is like the best place for me to be on a Wednesday. But thank you very much, everyone.
Good.
Okay.
Thank you.
Thank you.
Thank you all. Thank you. Thank you.
And
Rustam ji.
message, if
Thank
you
you,
have
guys.
question, message on the chat group, and we'll try to answer as much as we can.
Yeah, thanks, Saurabh.